Okay, this is NOC, Northern Oklahoma College, College Algebra, Math 1513, 7th edition, Offman Barker Nation. I'm in section 1.1. Okay, I'm working it's an example for number 19 on your homework. It's just like number 19. And you see a monster like this, where do you start? Well, I always start by scribbling off to the side here. Whoops, let's try this again. Okay, let's start over. I always start by scribbling off to the side here my order of operations. Remember, parentheses, exponents, multiply and divide, and then add and subtract. I'm looking at my parentheses, and I see this set of brackets, and I see this set of parentheses inside. And we want to remember to always work from the inside out. So this pair of parentheses here is inside the pair of brackets. So we're going to work on that pair of parentheses first. And then we'll work on getting rid of the brackets. And all this falls under parentheses. We got to get rid of the parentheses and the brackets. So let's start inside there. I look and I see if I have any like terms that I can add together. I have a y and a 1. That's a variable and an integer. They're not like terms. I can't put them together. So I'm going to say I'm done with the parentheses on that. I look for exponents, anything raised to a power. I don't see any. Excuse me. So now I'm doing multiply and divide. And I can multiply right here, the negative 2 times the y, and the negative 2 times the negative 1. So I'll do that multiplication. Negative 2 times y is negative 2y. And negative 2 times negative 1 is a positive 2, because the negative times the negative is a positive. That's enough for this step. I'm just going to bring down everything I didn't mess with. So anything I didn't touch, I'm going to bring down. Okay, that's where we are now. So I've gotten rid of the parentheses using multiplication. And now I look for, I'm still inside the parentheses, I look for addition and subtraction. I see here that I have a y here, and an integer here. I can add those y's together. They're like terms. So 3y minus 2y is 1y. I would rather have black ink there. Is 1y. But remember, we're pretty lazy, so we just leave that 1 off. Alright, so I got my y's put together and got 1y. My plus 2 comes down. My brackets are still there because notice I haven't done that times 6 out front there. So I still have brackets. I still have to leave those grouped together. Bring everything else down. Don't forget that you have a fence here on the equal sign, keeping your left and right side separate. Alright, where do I go from here? I did my addition and subtraction. Well, I start all over. E, E, M, D, A, S. Because I still have some parentheses that I'm getting rid of. So, can I add the y and the 2? No. One's a variable, one's an integer. So I can't add the inside the parentheses. Nothing's being raised to a power. So I must have some multiplication and division to do. And I look and I see that I can multiply the 6 times the y and the 6 times the 2. So that's what we'll do. 6 times y is 6y. 6 times 2 is 12. And remember, a positive times a positive is a positive, or a plus. It means the same thing. Bring down your minus 2 and your plus 7y, and your equals 0. And that's where we're at so far. We've done all the multiplication and division. Next, I look for addition and subtraction. So I'm looking here for like terms. I see a y term here and a y term here. Those are like terms. 6y's plus 7 more y's is 13y's. So I have 13y's. Now while I'm at it, I see that this is an integer and that's an integer. And I can add those like terms together. So I put a positive 12 and a negative 2 in my calculator, and I get a positive 10, or a plus 10. It means the same thing. Equals 0. Okay, and we've taken care of our addition and subtraction. All that we have left is isolating the y. Remember, we want to get the y all by itself. So let's see if we can get the y alone. Which do I get rid of? Do I get rid of the 13 first, or do I get rid of the 10 first? And remember, we talked about in an earlier problem, get rid of the number that's furthest from the x or y. So the 10 is further away. It's a plus 10. How do I get rid of plus 10? By doing the opposite. Minusing 10. The opposite of plus 10 is minus 10. Don't forget to do it to both sides. That cancels out, and now I have 13y equals negative 10. And my last step is to get rid of this 13. Now remember, that is 13 times y. How do I get rid of times 13? I divide by 13. I divide by 13, and my final answer is the fraction negative 10 over 13, which you can change to a decimal if you want to, but it's fine to leave it as a simplified fraction. Okay, now for an example for problem number 21. We have this nasty thing. It's a fraction, and there's our fraction. It's set equal to another fraction plus a whole number, and that's a mess. We got to figure out what x is. So we have a lot of stuff to do to get that x alone. Most people are scared of fractions, so there's a trick to getting rid of fractions. And to get rid of fractions, the easy way is to multiply everything by the lowest common multiple. Okay, what is the lowest common multiple? Okay, when we look for the lowest common multiple, we're asking ourselves, what is the lowest number that 3 and 4 both go into? Here's our 4 and here's our 3. Don't worry about the negative right now. So we're looking for the lowest number that 3 and 4 go into. Well, there's lots of numbers that 3 and 4 go into. They both go into 12, they both go into 24, they both go into 36, they both go into 48, and so on forever. We want to pick the lowest common multiple, the lowest number that both of them will go into. The reason we pick the lowest is it's less work for us. If we take 48 and multiply everything by 48, we're going to have some really big numbers that we have to deal with. So we want the lowest number they both go into because it's less work. Okay, all I've done is rewritten the problem, and what I've done is I left a little space in between each part of the problem here. So I left a space in front of this fraction, I left a space in front of that fraction, and I left a space in front of the 2, and that's where we're going to multiply everything times 12. See, the whole idea is we're going to multiply this entire expression by 12. All right? So think of it as the distributive property. That gets multiplied by 12, and the second fraction gets multiplied by 12, and the 2 gets multiplied by 12. Everybody's getting ready to be multiplied by 12. We're going to show that here by multiplying this first fraction by 12 over 1. Now, why did I change 12 to 12 over 1? When you're multiplying fractions, it's just easier if they're both fractions. So I'm going to change the 12 to 12 over 1, because you can put any number over 1. Now over here, the 5x minus 7. Again, that's a fraction, and I want to multiply it by 12. Since it's a fraction, I'm going to multiply it by the fraction 12 over 1. Finally, on the end here, the 2, that's a whole number. So I'm going to multiply it by 12 and just leave 12 as a whole number that time because it'll be easier. All right, let's multiply these out. Now, it might help if I put parentheses around these little groups on top of the fraction. So when I multiply fractions together, now I have 12 times, remember when you put the number by the parentheses, it implies multiplication. 12 times the 12 plus x over 1 times negative 4 is negative 4 on bottom. Equals, let's do this multiplication, 12 times 5x minus 7, that's our numerator, that's on top, over 1 times 3 is 3. And then finally, plus 12 times 2, that's just the whole number 24. Okay, let's continue simplifying. Look at this part of the fraction. Just the 12 over negative 4. And ask yourself, what is 12 divided by negative 4? Well, that's just the whole number negative 3. 12 divided by negative 4 is negative 3. I'm going to bring down the parentheses, 12 plus x. And look, that fraction turned into whole numbers. We eliminated the fraction. That was the whole idea. Same thing over here. 12 divided by 3 is simply the whole number 4. And I'll bring down my parentheses, 5x minus 7. And the plus 24, pretty much simplified. I'll just bring it down as is. All right, looking good. Now it's just a huge simplification problem. And remember, I always like to write off to the side what order I'm going to do things in. PEMDAS, parentheses first. So I'm looking at my parentheses, and I'm looking inside here at the 12 and the x. Those are not like terms. So I can't add them together. Over here, the 5x and the 7. One is a variable, x, and one is a whole number, 7. They're not like terms, so I can't add them. But what I can do, I can't do parentheses. There's nobody being raised to a power. I can multiply. So I multiply the negative 3 times everything in the parentheses, and I multiply the 4 times everything in the parentheses. That's what we're getting ready to do. So negative 3 times 12. 3 times 12 is 36, and a negative times a positive is a negative. 3 times x is 3x, and a negative times a positive is a negative, so minus 3x equals 4 times 5x is 20x. Positive times positive is positive, so I just leave it alone. 4 times 7 is 28, and a positive times a negative is minus, or negative, and my plus 24 comes down. Okay, I've done my multiplication and division. Next, I'm looking for addition and subtraction. You know, I forgot to draw my fence on the equal sign here, so let's keep the left and right side separate. So I'm looking on the left side of the fence, and I see a whole number 36 and a 3x. One's a variable, one's a whole number. They're not like terms. There's nothing that I can add over here, so I just bring them down. But looking over here on the right side, I see an x term, a whole number, and a whole number. I can put those whole numbers together. They're like terms. So put a negative 28 together with a positive 24. Your calculator will verify that that's a negative 4. Your 20x we didn't mess with, bring it down. Okay, so we stand at negative 36 minus 3x equals 20x minus 4. Here's our fence. The whole idea is to get x alone on one side or the other. Now remember, we said when you have a choice, when you have an x on the left and an x on the right, eliminate the lower x. Well, negative 3x is lower. How do I get rid of a negative 3x? Well, think of it as a minus 3x. How do you get rid of minus? You add, you plus. So instead of minus and 3x, I'm going to add 3x. That's going to make the 3x go away. Now don't forget to do it over here on the right side. I'm going to put it under the 20x because they're like terms. And I'll put those x's together here in a minute. So now, on the left I have the negative 36, it's still there. I put my 20x and my 3x together for 23x. You can add like terms. My negative 4 is an integer out there all by itself. Okay, so we've got the x on the right side. And next to the x we have a 23, that's called a coefficient. And out here on the end we have a 4, a constant. Which one do I get rid of first? Remember I told you, get rid of the one that's furthest from the x. The one that's furthest from the x is this minus 4. Get rid of a minus 4 by adding 4. Make sure you do it to both sides. That makes the 4's go away. Negative 36 plus 4 is negative 32. And on the right side I have 23x. Finally, remember that 23x is x times, put a little dot in there, x times 23. How do you get rid of times 23? You divide by 23. You undo multiplication by using division. Do it to both sides. 23's cancel out. And x equals this fraction here, negative 32 over 23. You might use your calculator and check, make sure that fraction's simplified. You can express it like this as an improper fraction, or you can turn it into a mixed number, or you can even turn it into a decimal. But leaving it as an improper fraction like that is fine as long as it's simplified. Now something you may notice is that the x is on the right. This kind of freaks people out sometimes. The x is on the right side. It's okay if x is on the right. Okay? It's okay if x is on the right. The whole idea is to get x alone. We don't care if x is alone on the right side or if x is alone on the left side. We just want x to be alone.